To all of you in Sankalpa Education Pratham classes, I am Sachin Patel delivered lecture series on derivatives or differentiation. Right now we are going with the derivative of inverse trigonometric function, and we are going with the next type related to that derivative of inverse trigonometric function, which is by using the substitution. We know about the substitutions in a previous lecture, and right now we are going with thoroughly with that substitutions used inside the example as follow. Right now we have to consider y is equal to cos inverse inside the bracket 2 into x into square root of 1 minus x square is here, and we think about that expression is nothing but a 1 minus x square. That means we have to use the substitution is nothing but a sine theta and cos theta also, and therefore first of all we have to put the consideration of sine theta is here. Put x is equal to sine theta, and it implies that theta is equal to sine inverse x, because this sine is transferred here, then it becomes a sine inverse x, and x is equal to sine theta. Put it inside that expression. Y is equal to cos inverse inside the bracket 2 into sine theta into square root of 1 minus sine square theta, because x is equal to sine theta and therefore x square is nothing but a sine square theta, and here cos inverse inside the bracket 2 into sine theta 1 minus sine square theta is nothing but a cos square theta, and square root of the cos square theta is nothing but a cos theta is here, and 2 into sine theta into cos theta, and this is nothing but a double angle formula, and which is nothing but a cos inverse sine 2 theta, cos inverse sine 2 theta. And right now here we have to see that cos inverse is outside and sine is inside. Therefore we want to use the allied angle formula related to sine to convert into cos as follow. That means cos inverse inside the bracket cos pi by 2 minus 2 theta is here, because x is nothing but a 2 theta, and therefore cos pi by 2 minus 2 theta is here, and cos inverse are cancelled to each other, and y becomes equal to pi by 2 minus 2 theta. But we know that the theta is equal to sine inverse x. Putting this value here, you will get the consideration of y is equal to pi by 2 minus 2 into sine inverse x, 2 into sine inverse x, and therefore y is equal to pi by 2 minus 2 into sine inverse x. Y is the function of x, and therefore we have to get the derivative of y with respect to x. Therefore dy by dx is equal to pi by 2 having derivative 0, minus 2 is a constant, and sine inverse having the derivative 1 divided by square root of 1 minus x square. That means answer is minus 2 divided by square root of 1 minus x square is here. This is the answer. Similarly, you can find out the derivative of this function by using x is equal to cos theta, and by using cos theta you will get the similar answer for that substitution. Right now we are going with this expression. This expression is very similar with the 1 minus tan square theta and 1 plus tan square theta, and therefore we have to use the substitution here. First of all, we have to create this expression or this term as a complete square, and for this purpose, first of all, y is equal to cos inverse inside the bracket 1 minus 3x bracket square is here. 3x bracket square is nothing but 3 square is 9 and x square is here. Similarly 1 plus 3x bracket square, and right now we have to substitute this 3x by tan theta, and therefore put 3x is equal to tan theta here, and it implies that theta is equal to tan inverse 3x. Theta is equal to tan inverse 3x. By putting that 3x is equal to tan theta inside the expression, you will get the y is equal to cos inverse inside the bracket 1 minus tan square theta divided by 1 plus tan square theta. 1 plus tan square theta, and 1 minus tan square theta divided by 1 plus tan square theta is nothing but a cos 2 theta, and therefore you will get the cos inverse inside the bracket cos 2 theta. This is the formula of cos 2 theta, and therefore cos 2 theta is there. Cos and cos inverse are cancelled to each other, therefore you will get the 2 theta. Y is equal to 2 theta, but theta is nothing but a tan inverse 3x is here, and putting this value here you will get the y is equal to 2 into tan inverse 3x. 2 into tan inverse 3x, and therefore y is the function of x, therefore derivative of y with respect to x, derivative of y with respect to x is dy by dx is equal to 2 is a constant here, and tan inverse theta, we know that the tan inverse derivative of ddx of tan theta, tan inverse x is equal to 1 divided by 1 plus x square is here. Derivative of this one is nothing but a 1 divided by 1 plus x square, and x is replaced here 3x, and therefore first of all we have to get the consideration of 1 divided by 1 plus 3x square into derivative of 3x is taken here is nothing but a 3, and therefore you will get the complete answer related to that one is 6 divided by 1 plus 9x square, and this is your answer related to that one. This is your substitution related to that one. Right now we are going with the next example related to that one as a follow. Now these are the another example related to substitution of derivative of substitution by using a particular substitution here. It is similar with the a minus x divided by a plus x, and a is nothing but a 3 is here, and therefore we have to put the consideration of put x is equal to a cos 2 theta. That means you have to, a is nothing but a 3 is here, and therefore 3 cos 2 theta, 3 cos 2 theta, and by putting this value inside this expression y becomes y is equal to tan inverse inside the square root of 3 minus 3 cos 2 theta divided by 3 plus 3 cos 2 theta. 3 cos 2 theta, and 3 is taken common from both numerator and denominator, and you will get the consideration of tan inverse inside the bracket square root of 3 is taken outside 1 minus cos 2 theta, and divided by 3 is taken outside 1 plus cos 2 theta is here. 1 plus cos 2 theta is here, and 3 are cancelled to each other. We will get the tan inverse inside the bracket square root of 1 minus cos 2 theta divided by 1 plus cos 2 theta. Right now we know that the double angle formula cos 2 theta, it is equal to cos square theta minus sin square theta. It is one formula. Second one is nothing but 1 minus 2 sin square theta, and another one is nothing but 2 cos square theta minus 1, and those are the formulae related to cos 2 theta. From these two formulas we can get the consideration of 1 cos 2 theta. 1 cos 2 theta is nothing but 2 sin square theta, because this minus 2 sin square theta is plus here, and this plus is minus here, and therefore 1 minus cos 2 theta is nothing but 2 sin square theta, and when this minus 1 is taken here, that means it becomes a plus 1 into cos 2 theta is nothing but 2 cos square theta, and putting those value here we will get the y is equal to tan inverse inside the square root 2 sin square theta divided by 2 cos square theta. 2 and 2 cancel to each other, and you will get the consideration of sin square theta divided by cos square theta is nothing but a tan square theta, and therefore tan inverse inside the square root tan square theta, and the square root of tan square theta is a tan theta, therefore tan inverse inside the bracket tan theta, and you will get the tan inverse tan cancel to each other, theta is here, y is equal to theta. Right now we are going with once again substitution is here. Substitution is nothing but x is equal to 3 cos 2 theta. Therefore first of all we have to transfer this x. First of all we transfer this x 3 here. You will get the, it implies that x divided by 3 is equal to cos 2 theta, is equal to cos 2 theta, and is equal to cos 2 theta. This cos is transferred here, then you will get the, it implies that 2 theta is equal to cos inverse x divided by 3. 2 theta is equal to cos inverse x divided by 3, and this 2 also transferred here, then you will get the theta is equal to 1/2 cos inverse x divided by 3. Now theta is equal to this value is taken inside this expression. Y is equal to 1/2 cos inverse x divided by 3, and y is the function of x, therefore derivative of y with respect to x is nothing but dy by dx is equal to 1/2 is a constant taken as it is, and derivative of that cos inverse, derivative of cos inverse is nothing but a minus 1 divided by square root of 1 minus x square. That means square of that one is nothing but a x square divided by 9 into derivative of that x divided by 3 is nothing but a 1 divided by 3 is there, and we have to get the 1 divided by 3 into 1 divided by 2, that means 1 divided by 6, that minus into 1 divided by square root of, we have to make denominator same by multiplication, and you will get the 9 minus x square divided by 9 is here, 9 minus x square divided by 9, and root of 9 is nothing but a 3, and therefore minus 1 divided by 6 into 3 divided by square root of 9 minus x square, and you have to cancel 3's from here. You will get the minus 1 divided by 2 into square root of 9 minus x square, and this is your derivative of that expression is here, and you will get the consideration of this one. Similarly, you can find out the derivative of this expression, or this another example is here. First of all, we have to going with the consideration of 1 minus x square. That means we have to put the x is equal to sine theta here, and therefore put x is equal to sine theta. That it implies that theta is equal to sine inverse x. You have to we have to throw that sine x from right hand side to left hand side. At that time it becomes a sine inverse, and therefore y is equal to sine inverse inside the bracket 5 into square root of 1 minus sine square theta minus 12 into sine theta divided by 13 is here, and once again you have to get the consideration of sine inverse inside the bracket 5 into 1 minus sine square theta is nothing but a cos square theta, and square root of cos square theta is a cos theta is here, cos theta minus 12 into sine theta, 12 into sine theta divided by 13. Right now we have to get the expression is similar to type of first value is nothing but a 5, square of that 5 is nothing but a 25, and square of the 12 is nothing but a 144, and addition of these two is nothing but a 169, and square root of that 169 is nothing but a 13, and that means the derivative that means the addition of squares of these two numbers is addition of squares of these two numbers, and square root of that addition is present inside the denominator, and therefore it is a one type which is already known to you. This 13 is a denominator of these both terms, and therefore sine inverse inside the bracket 5 divided by 13 into cos theta minus 12 divided by 13 into sine theta, 12 divided by 13 into sine theta. Now we have to put once again sine inverse is outside, and therefore we have to get the alternate here, and therefore 5 divided by 13 is equal to sine alpha, and as usual 12 divided by 13 becomes cos alpha, and therefore y is equal to sine inverse inside the bracket sine alpha into cos theta minus cos alpha into sine theta is here. Cos alpha into sine theta is here, and therefore you will get the consideration of sine alpha cos theta, sine alpha cos theta, and cos alpha sine theta is here, and by using consideration of sine A into cos B minus cos A into sine B, you will get the sine inverse inside the bracket sine alpha minus theta is here, and sine and sine cancel to each other, alpha minus theta is remained here, but theta is nothing but what? Theta is nothing but a sine inverse x, and therefore you will get the y is equal to alpha minus sine inverse x. Y is equal to alpha minus sine inverse x. Theta is equal to sine inverse x. Put it inside the expression, you will get the alpha minus sine inverse x, and therefore y is equal to alpha minus sine inverse x. We have derivative of y with respect to x. With respect to x is nothing but dy by dx is equal to alpha having derivative 0 minus sine inverse x having derivative 1 divided by square root of 1 minus x square, and therefore derivative of this is nothing but a minus 1 divided by 1 minus 1 divided by square root of 1 minus x square. This is your derivative of this one. These are the examples related to substitutions. We have to get the another examples related to that substitutions in next lecture. If you like that video, please subscribe my channel and press on bell icon to get the next notification related to that lecture series related to derivative. Thank you.